Hey guys, BuildZoid here, and today we're going to be unboxing and disassembling this RTX 3060 Ti that I bought, so thank you to the Patreons for making purchases like this one possible. And yeah, let's just get right into it, because there's not really much else to say, and I'm really interested in what this card is like, because I tried to look up, well, so basically, I bought this for around 611 quid, so it's basically one of the cheapest 3060 Ti's, at least from what I could find. So, you know, I'm kind of concerned that it's gonna suck. Because things that are cheap normally do. Let's see what's in here. We've got... And there's the card, so we've got a quick user guide. I hope there's stickers. This is kind of cute. Not that I need it. That's not stickers. I don't know what it is, but it's not stickers. That. What's this? And that's another quick install guide. Okay, cool. Not much there. Is that really it? I guess that's what you expect when you're literally... Yeah, that's it, actually. There's no accessories of any kind, which I guess makes sense since this really is one of the cheapest 3060 Ti's I could find. It's not literally the cheapest. There was some that were like just under 600 quid. The thing is, the heatsink on those had me very concerned that they would run hot and loud after what I want to do with them. So, zoom in a bit and get it out of the anti-static. So, go. Oh, it's got a metal backplate. I was kind of worried this would be one of the... Is that metal? Yeah, that's metal. Yeah, because MSI apparently does this thing on some of their cards where they have like a carbon-enriched plastic backplate. They call it graphite, which is... or graphene? And I think they call it a graphene backplate, which is just like... Probably not, but anyway. No, this one's metal, at least as far as yeah, that's metal. Yeah, that's definitely metal. We have a warranty void if removed sticker. So at this point, we better hope that this card actually works, because I'm not going to be able to RMA it. Is there any... Oh, okay, there's no other screws. I did try to do some research on the card ahead of time, but I couldn't even figure out how many phases this is going to have. I really hope it's an 8-phase, because I do know that the PCB is capable of having an 8-phase VRM on it, but yeah, I couldn't find any pictures of one of these actually disassembled. So, yeah, let's see. Looks like there's going to be a base plate. Nope, no base plate. This is just the VRM heatsink. Wait, where does... Okay, yeah. No, so there's probably a brace running along the top. But I don't think it's a full base plate. Maybe for the memory? We'll see. Pull that off. And... Oh, right. They also have it screwed in over here. I'm not really a fan of this whole idea of having like these paths through coolers where then you block off a bunch of the airflow by extending the backplate past the end of the card. I'm kind of thinking of doing a test where we run where I check the not VRM, check the thermals of the card with this backplate installed and without it. Now, at low RPMs, this probably doesn't make much of a difference, because if you're not pushing that much air into the fin stack, then obviously you don't need a huge exhaust hole for it. But I think at higher RPMs, this probably, like, one, it'll produce noise, just because if you have air trying to force itself past a restriction, that always creates some amount of noise. And the faster you're trying, like, the more air you're trying to push through said restriction, the louder it gets. And then the other thing is just at higher RPMs, this would actually, act as more of an airflow restrictor than at lower RPMs, just because you have more air trying to get through the same size hole. So anyway, it should just come apart at this point, I think. Yeah, I mean, we have this brace bit up here, and that really does look like just a brace. Oh, there we go. And this is one of those cards with a bunch of annoying wiring. Well, this is easily accessible at least, but let's see. Come on. There we go. These are at least easily removed. It's not as stubborn as some of the cards I've dealt with. And there we are. And it's a 7-phase. My disappointment is immeasurable and my day is ruined. Really? A 7-phase? Are you kidding me? Like, come on. Like, they really, like, it is, like, yeah. So there's your Vcore VRM, and that is a 7-phase. Which, it's not the end of the world, but I was really hoping for more. So that is a funky looking inductor. This one over here. It's got, like, little, like, bits of the coil sticking out of it, because, like, there's little copper wires sticking out the side of it. Honestly, it looks like it got smashed. No? No, don't. Okay, it's not broken. But at a glance, that really looks like it got smashed by something. Like, that it got chipped off. But no, they have another one that looks exactly the same up here. So those are some those are some funky looking inductors. 2-phase memory VRM, controlled by a 1666. So this will be very easy to vault mod, which is of course one of the things I want to do with the card. We do have input or board protection fuses. They're not really to protect yeah. Calling them input protection fuses just doesn't make sense. The point of these fuses is if a component on the card fails, those are hopefully going to disconnect the failed component from power before that failed component can cause further damage. So those are, a nice addition to have on a card. Well, just discrete MOSFETs for the 2 phases of the memory VRM, which should be more than plenty. There's no... actually, no, they do have that sunk with... Is that... Looks like they folded the fins over in that area. Okay, that is a very sticky pad, and I'm pretty sure it'll just come apart. Okay, no, you can kinda... Yeah, you can tell. The fins are folded over there, so that's just to increase the surface area contacting the actual thermal pad so the thermal transfer is better. So I guess let's finish taking it apart. Get the backplate off and the brace. Oh. Guess I should have checked what MOSFETs this is on as well. And it is on AL00, so that's the 55 amp or 50 amp alpha and omega semiconductor parts. So, the usual for a 30 series NVIDIA GPU. So, yeah, I'm pretty annoyed that it's not an 8-phase. It's not a huge deal, right? Because going from 7 phases to 8 phases, it's not that big a difference, but I did want an 8-phase. Like, ideally, I wanted to get an NVIDIA GPU with one of the really weird power stage configurations, like one of the... Like, MSI has a 3070 Ti where they have 11 power stages for Vcore, and that would have been really cool to take a look at, just, like, how does that VRM operate? Because how do you get 11 power stages onto an 8-phase voltage controller, right? Like, there are controllers that'll do 11 phases, that's fine, but that 3070 Ti does not use one of those controllers. But unfortunately, this is just a very boring 7-phase configuration. Like, there's other cards that had 7-phase VRMs before, because, yeah, the controllers just kind of support that kind of phase count natively. Now, that one's annoying to get at. And... oh, there's one more screw. that's the card taken apart. We've got some thermal pads on the back of the card for sinking heat from the back of the card into the back plate. So that's a really good thing that it's actually made out of metal. And then here's the back of the card, and there's really not much here. Yeah, actually, there's basically nothing there. But the voltage controller. Whoa, they just rammed the voltage controller right under the display outputs. That is a weird place to put that thing. I would have expected to see that up in this area, right? Like, they've got all this empty space up here. But no, they put it right over here, which I guess simplifies the layout of the PWM signals directly to the actual power stages. But, yeah, anyway, that's not like that necessarily causes any issues, and the controller in use is a UPI semiconductor UP9512, so, you know, the typical sort of second to the bottom power voltage controller for 30 series NVIDIA cards, and that is the 95R, it's not the 9512R, not the 9512S. We've got some SP caps right behind the core, 470 microfarads each. Also some larger multi-layer ceramics over here. Not very much to the card. I wish we had a PCB layer count, but I guess that's wishing for too much. Actually, what's this chip? What is... Oh, that's some kind of controller for the... that looks like a RGB control chip up there. Because it's ITE something, so... Yeah, that's not a VRM controller, so I don't care what it actually does. We have a shunt resistor over here, of all places, for some reason. Then again, this is an NVIDIA GPU, so I guess I shouldn't be too surprised. And then our shunt monitoring chip is this chip down here, and that looks to be an NCP45491. So, yeah, I was really hoping for an 8-phase, but I guess when you're buying literally one of the cheapest 3060 Ti's that's currently available in the UK, you can't expect too much. And the heatsink, at least, you know, we've got a large fin stack, 2 fans, so the heatsink looks good, which was one of my other concerns, was like, I did want as much VRM as possible and also as much heatsink as possible. We've got, what, 5 heat pipes running through this thing? Yeah, we've got 5 heat pipes. That's actually kind of a lot. Yeah, that's actually a decent heatsink. I wonder what the base plate's made out of. Okay, that's like it's probably an aluminum base plate. And then it looks like we have a nickel-plated copper centerpiece, actually. I'm just going I'm just going to dig into that, because I do want to know, is it actually, like, it probably is. Yeah, that's copper. Yeah, you can see the copper through that. Or at least I can. Yep, that's definitely just nickel-plated copper down the center. So, yeah, nice enough, I guess. Yeah, I mean, nice enough card. In terms of modifications, my main, sort of the main one I'll be doing is just removing the power limit. That's going to go. And I'm going to be doing that directly to the NCP45491, not going to be trying to do that on the shunt resistors. Like, yeah, you can technically mod the shunt resistors, but, well, actually, so this is on 5 milliohm shunt resistors. The thing is, so, I do have the option to replace the existing shunts with 3 milliohm shunt resistors, which would probably give me around a 60% increase in power limit, roughly, as we would be decreasing the measured power consumption by about... Actually, no, it would be less than that. But, yeah, that would reduce the measured power consumption by something like 40%. But what I'm thinking of doing is just sort of faking the voltage reading from the shunt resistors and just disconnecting the actual monitoring chip from them completely, which basically means the card will have no actual power limits except what the fuses are willing to tolerate. And I'm assuming those are 20 amp fuses, especially since they seem to be using the same size fuse on both the 8-pin and the 6-pin. So the 20 amp fuse on the 6-pin is arguably a bit big, but the 20 amp fuse on the 8-pin is actually like that's a sensible size for a fuse that you would connect to an 8-pin power connector. Oh, it just says 20 on them. So yeah, those are 20 amp fuses over there. I'm surprised they didn't fuse the PCIe slot. Like, they fused the 8-pin and the 6-pin, they didn't fuse this PCIe slot, from what I can see. And, yeah, that's kind of it. We've got some options for adding capacitors to the memory over here. That looks like it's, yeah, that's for Vcore. Got more options for Vcore over there and here. More memory capacitors down here. So it'll be interesting to take an oscilloscope to this thing. It's been I've not really taken the oscilloscope to many NVIDIA GPUs in general, so that's another one of those things, like, it would be really cool to see how this runs. So, yeah, I have a 3060 Ti now. I don't think this really needs a full PCB breakdown. I mean, it's going to be very similar in terms of VRM heat output to an 8-phase 3060 Ti, and I've already done a PCB breakdown of one of those, except slightly higher and slightly hotter because said heat output, like, this is going to have roughly the same efficiency, except the heat is spread across only 7 phases instead of 8. So, yeah, it's going to run hotter, that's for sure. I'm not really a fan of the fact that, like, on the back of the card, right behind the power stages, all we're seeing is just traces. I'm not really a fan of that, because at least if you have the layer count, it's pretty normal for, like, higher layer count boards to just have a ground fill directly behind the power stages, because it helps with heat dissipation a bit. But MSI evidently didn't have the layers spare to do that here. So, yeah, again, that's one of the reasons I'd love to have, like, as far as I can tell, there's no layer count indicator. So, yeah, I'd love to know how many layers this is. If I had to guess, this is 8. Might be 6, though. Yeah, anyway. So mods basically are going to be remove power limit one way or another. Actually, maybe we'll do multiple stages of power limit removal. We'll start with just replacing the shunt resistors, see what that does, and then move on to more drastic measures. And then I wonder if I could add the phase back on. Not that I have... Nah, that's... See, the thing is, there's like a bunch of supporting SMD components for the power stage. And yeah, I'd need to populate those myself. And I really don't think that, like, that's going to take way too much effort. So we're not doing that. But yeah, so definitely want to get oscilloscope measurements for the memory, oscilloscope measurements for the Vcore. From behind the core, we're not going to measure that at the VRM. So probably going to be measuring off of these multi-layer ceramics over in this area, right around the center. I guess we could do also a power loss test on the PCB, just measure how much power we're losing from, like, say, this inductor to there. Though, I think the power plane is sort of biased up towards this area. At least that's what it looks like on a lot of other 3060 Ti's. So maybe I'll do, like, a check of voltage over here, voltage over there. Like, voltage at this inductor, voltage at this inductor, voltage at, like, the top inductor, and then voltage right behind the core. There shouldn't be too much difference. Like, it is a GPU. So, yeah, but I guess we'll see if I'm right about that. I don't know, over this distance of PCB, and with the fact that there's no memory chips in the way, I wouldn't expect too much of a voltage drop getting from the VRM to the core. Oscilloscope measurements for the memory as well, because I do want to, like, we have capacitor, mounting points for the memory rail, so if I'm going to be populating those, I do want to have a, like, comparison data. Probably going to be taking the oscilloscope measurements from this memory module, because the memory VRM is sort of centered relative to all of the memory chips. So, like, ideally, if there was memory chips over here, I'd be measuring from those, but obviously there's nothing there because this is a 3060 Ti. Yeah, so there, that's That's actually my thoughts on this 3060 Ti. Oh, and I guess volt mods as well. So power limit, cap mods, volt mods, you know, the usual approach. Um, and when I say volt mods, I mean we're gonna just mod the ref in circuitry of the UP9512. So NVIDIA GPUs, for those of you who don't know, use a voltage control standard called PWM vid, where the GPU core sends a PWM signal to the voltage controller. That voltage controller then filters that into a DC voltage level. And that DC voltage level then gets fed, like that circuitry actually goes slightly out of the controller and then back into it at a pin called ref in. Whatever the voltage at ref in is the voltage you get on the output of the VRM. So what I'll be doing is, I'm not sure if I'm going to do a full manual voltage control. I'm thinking of just having an offset voltage control where we can just add extra voltage on top of whatever the GPU is requesting. Though I might have a full manual override as an option. Yeah, I'm probably going to do a full manual override as an optional sort of setting. Because basically for that, you would just disconnect the PW. So there's an output for the PWM, like the PWM vid comes in, and there's like a PWM vid output pin. So we would just have to disconnect that output pin, which is called vid buff. Yes. So vid buff, there's a vid buff pin. You would disconnect the vid buff pin from the ref in circuitry, and by doing that, you disconnect, like you completely disable the ability of the GPU core to change the core voltage. That is usually what you would do if you want to run one of these cards on LN2. At ambient, I actually think that would probably suck, which is why I'm thinking of, like, you know, having a switch basically to disconnect and connect and disconnect the mod, and then also a switch to disconnect and connect the vidbuff pin so that we can run in both voltage offset mode and voltage override mode, which would be kind of fun, because I've never bothered to actually implement one of my volt mods that well. Like, I've done an offset mode one, and I've done a override one, but I've never done one where you had the option to switch between the two modes. Not that there's much to it, you just add an extra switch. And then the UP1666, I mean, this is GDDR6 memory. Actually, who's GDDR6? This is SK Hynix. Oh, so yeah, this will be interesting. Hopefully this scales with voltage. The GDDR6 on, say, a 2080 Ti did scale with voltage. The GDDR6 on a 6900 XT doesn't really scale with much of anything. Yeah, hopefully this scales with voltage, so bumping up the memory voltage from like 1.35 volts, which is the stock voltage, to maybe 1.4, 1.45, might translate to slightly higher memory clocks. And we can do that by modifying the PWM vid circuitry of the UP1666, which is my favorite thing about like modern NVIDIA cards is the PWM vid standard. It's so easy to volt mod these things. And also they just use it everywhere. You have PWM vid for the memory, you have PWM vid for the core, and, well, that's actually sort of the only two rails where you need it, because the other rails, like the 1.8 volt rail and the PEX rail, you don't really need them to go up and down in voltage. Like, the PEX always sits at, I believe, 0.95 volts, and the 1.8 volts always sits at 1.8 volts, which is why it's called 1.8 volts. So yeah, and I think PEX is this. 1.8 volts might be this. Not entirely sure about that. But, yeah, also, is that a... What component is that? And it looks like we've got a little 5 volt regulator over here, which is just for providing power to the actual power stages. So, okay, now I am actually done talking about this card. So yeah, it should be pretty interesting. I don't know, hopefully by the time I'm finished with it, this is one of the fastest 3060 Ti's ever. And then once I'm done with it, the plan is to stick it in my daily system. With all the modifications still attached, I'm not going to take them off. I've run modified cards in my daily in the past, so I really don't see a reason not to run, I'd like to run, hardware in my daily that's actually sort of, like, reflective of what I do on the channel, and, I've dailied modded cards in the past. I've modded a card for someone who ended up dailying that card with all the modifications still in place. Actually, that was the plan from the start. It was just, do some basic modifications that'll work well for daily. And so yeah, there. That's it. So, if you're considering this card, the PCB itself, I don't see really anything wrong with it. It is just a 7-phase Vcore, but, for the price, I think that's acceptable. The backplate is made out of metal. They are using it for sinking heat from the memory chips, so that's nice to see. Heatsink looks good. We'll find out if it actually is good when I get around to running this thing. But yeah, my initial impressions are pretty good, and the card is very modifiable, as we have, this has a public documentation, the 9512 has public documentation, or at least I have the data sheet for the 9512, and I downloaded that from UPI's website at one point in time. That data sheet, I feel like they might have taken it down again, but too late, I have it. So, fun fact, if you find any documentation for, if you're like modifying or repairing GPUs, and you find any documentation for any like voltage controller or anything like that, download the documentation. Thinking of which, I've just noticed looks like we have probably a 7-volt regulator over here for the gate drive of the MOSFETs. Yeah, I need to power this card up and check all the different voltage rails, and then I might post a diagram of what the stock voltages and also the stock resistances are for this card, because that should be helpful if anybody has, like, if in the future anybody needs to repair one of these. So, okay, now I'm done with the video. Finally done. So there. Thank you for watching. Thanks to the patrons and Teespring purchasers. So all the various AHOC supporters for making this purchase possible. And yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support AHOC so that I can go out and buy things like this 3060 Ti here, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check the links out in the description to them. Yeah, there. I don't know how to end that sentence, but I do know how to end the video by just reaching for the stop button. So, goodbye, and thanks for watching.